Hello and welcome to all my lovely students out there. Today we will start with a new chapter, Arithmetic Progression. Before we get into arithmetic progression, let us first understand certain sequence of number. What am I saying? Sequence of number. Sequence. What is this sequence? Sequence is a pattern of arrangement of numbers. These numbers follow a definite rule or pattern. I have given you some example that will make it easy to understand. See the sequence of numbers here. 1, 4, 7, 10, 13, 16 and so on. So when you look at this sequence, what is sequence? Sequence is an arrangement of number wherein these numbers follow a definite rule or pattern. Sequence is arrangement of numbers where the numbers follow a certain rule or they follow a certain pattern, that is fixed pattern. So if you look at the first sequence, you can see that after 1, when are we getting 4? 1 plus 3 will give you 4. 4 plus 3 will give you 7. 7 plus 3 will give you 10 and so on. This is called as sequence. Okay, sequence is arrangement of numbers where the numbers follow a definite pattern or rule. See the next sequence. 1, 4, 16, 64, 256 and so on. What is the pattern here? Let us observe it closely. See what is the pattern here. 1, 4, 16, 64, 256 and so on. From 1, how will you get 4? Is it by adding? By adding 3 you are getting 4. But plus 4 plus 3 is not 16. So here the sequence, the pattern is something else. This sequence follows some other pattern. Let us again think. Yes. 1 into 4 will give you 4. 4 into 4 will give you 16. 16 into 4 will give you 64. 64 into 4 is giving you 256. So here the pattern is in another way. There in the first case you saw that when you added plus 3, when you added 3 to each term, you are getting the next term. Okay, so this is one type of sequence. Second type of sequence, now this is the third type. 1 square, 2 square, 3 square, 4 square. What will be the next term? Obviously 5 square. But are we getting the second term by adding a fixed number? Let us see. Suppose 1 square is 1, 2 square is 4. Okay, here again we can take it as 1 plus 3 will give you 4. So, next number should be 7. But as per the sequence, the next number is 3 square is 9. 4 square is 16. Let us check the second pattern, how we got the second sequence. Let us check that method. 1 into 4, 4. Okay. 4 into 4, 16 should come, no? But we have 9. So here, neither by adding you are getting the next term, neither by adding you are getting the next term, or neither by multiplying. When you multiply or when you add by a fixed term, you are not getting the next term. Here, the sequence is something else. We know what is the sequence. This is square of natural numbers. 1 square, 2 square, 3 square, 4 square. Next will be 5 square, 6 square, like that. But this sequence is not following the addition or the multiplication rule, which we got from the above two example. So this is completely another type of sequence. In this year, we are going to learn the first type of sequence where you will get the next number by adding a fixed number. So let us think about the first example. What did I say? This year, we will be talking about a different type of sequence where you will get the next number by adding a fixed number to it. What was the fixed number here? In the first example, it was 3, no? 1 plus 3 will give you 4, 4 plus 3 will give you 7, 7 plus 3 will give you 10, 10 plus 3 will give you 13. So by adding a fixed number, you are getting the next term. This type of sequence is called as arithmetic progression, where first term, second term, how will you get? By adding a certain fixed term to the first term. By adding a fixed number to the first term, you will get the second term. By adding that same number to the second, you will get the third. By adding that same constant to the third, you will get the fourth. This type of sequence of number or arrangement of numbers is called as arithmetic progression. Now here, when you multiplied the first term by 4, you got the second. Again, second term, when you multiplied by 4, you got the third. Where you are multiplying by the same number. First case, you were adding by the same number. Second case, you are multiplying by the same number. When you multiply by the same number, this sequence is called as geometric progression. Geometric progression, but this you don't have to learn this year. You will be learning it later. Okay? When you add a fixed number, that type of sequence is called as arithmetic progression. When you are multiplying each term by a fixed number and you get the second term, that type of sequence is called as geometric progression. Just to understand what is geometric progression, next year you will be learning more about geometric progression. So this year we will be completely focusing on arithmetic progression. And the last that I gave you is not arithmetic progression, not geometric progression. This is just a sequence which follows some other pattern. Okay? This will not fall into arithmetic progression. This follows another pattern. In this chapter, we will be completely discussing about arithmetic progression. So let me take another example and explain it again. So let us discuss few more things related to arithmetic progression so that you get the definition of it clearly. I'll give you one more example. Let me take, I'll go for easy numbers. 2, 4, 6, 8, 10, 12. Here, this is a finite arithmetic progression where the numbers are finite. No, it is not never ending. The numbers are finite. Okay, the sequence is still here. Okay, this is finite arithmetic progression. How did I confirm that it is arithmetic progression? How will you check whether it is arithmetic progression or not? You will take the first term. The first term, let us take it as T1. T1 is 2. T2 is the second term, which is 4. Subtract second term minus first term. T2 minus T1 is equal to 4 minus 2, which is equal to 2. Understood? Now let me take the third term. T3 is equal to 6. Let me do again the same thing. Now the third term minus second term. T3 minus T2 is equal to 6 minus 4, which is equal to 2. So till now we are getting the difference same. Difference is a constant. Going on, T4 is equal to 8. Let me subtract the fourth term and the third term. T4 minus T3. Always you will subtract the second and the first. Third and second consecutive numbers. Okay? Second and first. Third and second, like that. Always subtract the number from the previous number. Okay? From its previous number. So T4 minus T3 will be, T4 is 8. 8 minus T3 is 6. Again 2. Now this, T5 is 10. So T5 minus the previous term is T4. Fourth term. Fifth term minus fourth term, which is equal to, fifth term is 10. Fourth term is 8. Again you are getting 2. Now last, T6 is given as 12. Do the same thing. Sixth term minus the previous term, that is fifth term, will give you 12 minus 10, which is equal to 2. So you can see that every term when subtracted from its previous term, Every term when subtracted from its previous term, you are getting a constant. 2, 2, 2, 2, 2. You are getting a constant. If you get a constant, you can assure that these numbers follow arithmetic progression. Understood? Okay. So if you are getting this sequence, you can confirm that these numbers follow arithmetic progression. I hope it is clear. Now few more terms related to arithmetic progression. What is arithmetic progression? Arithmetic progression is a sequence of numbers. You can put it any way. Okay, there is no hard and fast definition. You explain in your method. First type of definition is where sequence arithmetic progression is a sequence of numbers where the number subtracted from its previous term is a constant. Number subtracted from its previous term is a constant. This is one type. मतलब second number उसका previous क्या होगा? First. Third का previous second. Where a number subtracted from its previous term is a constant. That is one. So the second way how we can explain arithmetic progression is arithmetic progression is also can be defined as sequence of numbers where a number added by a certain amount will give me the second number. Where a number, suppose here, this is 2. 2 added by a fixed amount. What is that fixed amount? 2. 2 plus 2 will give me 4. A number 4 added by a fixed amount will give me the next number. So if you are adding a fixed amount to the first number, you will get the second number. If you are adding that fixed amount to the second, you will get the third number. This is also one way of defining arithmetic progression. Now let me give you another example. First let us check whether this is arithmetic progression or not, or just a sequence. This sequence, let us see whether it is arithmetic progression or not. So this first term is also called as A. A or T1. T1. What is T1? 5. T2, 4. T3, 3. T4, 2. T5, 1. How to check whether the sequence is arithmetic progression or not? Always you will subtract the term from its previous term. So this will be T2 minus T1, which is equal to 4 minus 5. 4 minus 5 is minus 1. Next will be T3 minus T2. T3 is 3 minus 4. 3 minus 4 is also minus 1. T4 minus T3. T4 is 2. 2 minus 3 is equal to minus 1. And T5 minus T4. T5 is 1 minus 2 minus 1. Difference is same. This term we will call it as common difference and the symbol is D. D is equal to minus 1. This is called as common difference or D symbol. We will use small letter D as minus 1. Same. So these numbers follow arithmetic progression. They are arithmetic progression. What is arithmetic progression? It is a sequence in which the difference between two consecutive numbers. Consecutive means one after the other. Difference between two consecutive number is the same. That is T2 minus T1, T3 minus T2, T4 minus T3 is the same. Difference between two consecutive numbers is the same. Sequence in which the difference between two consecutive numbers is the same. Write it and keep. This is called as arithmetic progression. I hope you understood and the terms related to that. The first term we denote it as A, or first term while solving you will write it as T1, T2. Okay, second term is first term T1, second T2, T3, T4 and T5. Okay. Practice set 3.1, first question. Which of the following sequence are AP? If they are, AP means arithmetic progression. Find the common difference. Okay, easy. we have already discussed 2, 4, 6, 8 and dot dot. So this is an infinite arithmetic progression. Okay, because it is going on. Let us write T1 as 2, T2 as 4, T3 as 6 and T4 8. How to check whether it is arithmetic progression or not? We will subtract two consecutive numbers. So 4 minus 2. T2 minus T1. 4 minus 2 is giving you 2. T3 minus T2. 6 minus 4 is giving you 2. T4 minus T3. 8 minus 6 is giving you 2. So everywhere you are getting the difference to be a constant. So here D is 2. When you get the difference to be constant, this sequence is arithmetic progression. Therefore, the difference between two consecutive numbers are same. Therefore, 2, 4, 6, 8 are in AP. Okay, are in arithmetic progression. And the next question is, what is the common difference? Yes, we have a common difference. Difference is same, one and the same. Common difference is 2. That's it. You will get your marks. Similarly, let us take the remaining sums. Second question. Okay, same way, let us write T1 is 2, T2 is 5 upon 2, T3 is 3 and T4 is equal to 7 upon 3. T1, T2, T3, T4. How will you check whether they follow arithmetic progression? You will subtract two consecutive numbers. One after the other numbers you have to subtract. So let us subtract second and from first, that is T2 minus T1 is equal to 5 upon 2 minus 2. 5 upon 2 minus 2. So this will be cross multiplication I will do. 5 into 1, 5 minus 2, 2s are 4 upon 2, which is equal to 1 upon 2. Now T3 minus T2. T3 minus T2 will be 3 minus 5 upon 2. Same way, denominators are different. I'll cross multiply. 6 minus 5 upon 2. Yes, 1 upon 2. Next, T4 minus T3. T4 is 7 upon 3. We have written here. Minus T3 is 3. Means nothing, means denominator is 1. Cross multiply. 7 minus 9. Upon 3, which is equal to minus 2 upon 3. We are getting a completely different number as difference between fourth and the third term. So is the difference common? No, it has changed. So if you see that the common difference is not same, therefore the numbers don't follow, they are not in arithmetic progression. So you will write as the difference between two consecutive numbers is not the same, then copy these numbers and write are not in AP. In your textbook, if you see that the final answer is given as the numbers are in AP, then you should make a change into the question. I kept the question as given in the textbook. If you make this fourth term as 7 upon 2, then you will see that if it is 7 upon 2, then you will see that 7 minus 3 2s are 6 upon 2 will give you 7 minus 6 is 1 upon 2. Change the question, only then you will get the numbers in AP. Otherwise, if you keep the question as it is given in the textbook, They are not in arithmetic progression. Okay, so if you are changing the question, if you are writing it as 7 upon 2, are in AP, or if you are taking the question as given in the textbook, not in AP. Okay, any way you can write. But always follow the, don't go to change the question. Even if the question is wrong, you will be getting marks in your board exam. So don't change the question. Let the question be as it is until and unless they make correction. Third question, let us check whether they are in AP or not. T1 minus 10, T2 minus 6, T3 minus 2, T4 2. Okay, T4 is 2. Subtract T2 minus T1 is equal to minus 6 minus 10, which is equal to minus 6 plus 10, correct, which is equal to 4. T3 minus T2 is equal to, T3 is minus 2 minus of minus 6, minus 2 plus 6, which is equal to 4. Next, T4 minus T3 is equal to, fourth term is 2 minus 2, which is equal to 2 plus 2, 4. Common difference. The difference is same. Therefore, as the difference between two consecutive numbers, as the difference between two consecutive numbers is same, minus 10, minus 6, minus 2, 2 are in AP, are in arithmetic progression. And what about the common difference? Common difference is 4. Common difference is equal to 4. Common difference is equal to 4. Easy. Fourth question. T1 0.3, T2 0.33, T3 0.333. Let's subtract. T2 minus T1 is equal to 0.33 minus 0.3. Subtract. If you are confused, use working column. 0.33 minus 0.3 will give you 0.03. Okay. Next is T3 minus T2. T3 is 0.333 minus T2 is 0.33. Will give you 0.003. Correct? If you are confused, do it in working and check. 0.003. Is the difference common? No. Write the statement. As the difference between two consecutive numbers are not the same, this sequence is not AP. These numbers are not in AP. Okay. Sixth question. T1 minus 1 upon 5. T2 minus 1 upon 5. T3 also minus 1 upon 5. Subtract and check. T2 minus T1 will give you minus 1 upon 5 minus 1 upon 5. Minus and minus will get added. So, minus 1 upon 5 plus 1 upon 5 will give you 0. What about T3 minus T2? T3 minus T2 will be minus 1 upon 5 minus 1 upon 5. One and the same thing. So, here also you will get the answer. The difference as 0. So, as you can see, the common difference is same. It is 0. So, you will write these numbers are in AP. They are in AP and common difference is 0. Okay, write that statement and complete. Now, let's take the 7th sum. Okay, 5th sum you do on your own. It is easy. I will do the 7th and the 7th sum. 8th sum also you will do on your own. Okay, 7th sum I will do. 2 sums you try it out. The 7th question. T1 is equal to 3. T2 is equal to 3 plus root 2. T3 is equal to 3 plus 2 root 2. T4 is equal to 3 plus 3 root 2. I have written this. Now after this, let us find the difference. T2 minus T1 equal to, T2 is 3 plus root 2 minus T1 is 3. 3 minus 3 will get cancelled. 3 minus 3 is 0. So you are getting the answer as the difference as 2. Now let us go ahead. T3 minus T2 is equal to, T3 is 3 plus 2 root 2 minus, what is T2? T2 is 3 plus root 2. Okay. This is minus sign, so put it in bracket. Be careful. 3 plus 2 root 2 minus 3 minus root 2. No? Sign will change. So, now 3 and minus 3 cancel. What are you getting is 2 root 2 minus root 2. Out of this, you can take, this is one term, this is another term. What will you take common? Root 2 is common in both. So, I will take root 2 common. And what remains is, from the first term root 2 went, 2 remains minus. Second term root 2 went, now no number means 1. So, finally you are getting 2 minus 1, 1 root 2. 1 root 2 is nothing but root 2. Okay, so till now we are getting the common difference. Same. T2 minus T1 we did. T3 minus T2 we did. Now T4 minus T3. Now last is T4 minus T3. T4 minus T3, which is equal to 3 plus 3 root 2 minus, what is T3? 3 plus 2 root 2. See children, put it in bracket, otherwise everything will go wrong. This will be 3 plus 3 root 2 minus 3 minus 2 root 2. The sign changed. 3 minus 3 cancel. What you get is 3 root 2 minus 2 root 2. Same thing we will do. Both the terms, what is common? Root 2 is common. Root 2 ko bahar nikalo. What you get is 3 minus 2. 3 minus 2 is 1. 1 root 2 is nothing but root 2. So for all difference, it is same number. It is a constant. So you have a common difference. So if you are getting a common difference, then this sequence is in AP. So you will write, as the difference between two consecutive numbers is same, write this sequence and write R in AP. What about the common difference? Common difference is equal to root 2. Okay. What is the symbol of common difference that we will use? D. D is for common difference. I hope you understood these sums. Two sums, try it on your own. That is sum number 5 and sum number 8. Okay. Now the second question, very important. Write an AP. We should form an arithmetic progression where first term is A. I told you, first term we will be taking as A. And D is the common difference in each of the following. So A is equal to 10 means A is T1, which is 10. First term you know and the common difference also you know. The common difference D is 5. Understood? So if the first term is 10, what will be the second term? You should add that, no? Plus 5. 10 plus 5, 15. So let us write that. So T1 is equal to 10. T2 will be T1 plus D. First term plus common difference D will give you T2, which is equal to T1 is 10 plus 5, 15. So on. Now T3 will be T2 plus D. T2 plus D. T2 you got 15. 15 plus common difference is 5 will give you 20. T4 will be equal to the previous term plus the common difference. Previous term is 20 plus common difference is 5, 25. So what will be the possible AP. What will be the possible arithmetic? What is the correct arithmetic progression? First term is given as 10. So first term 10, comma. Second term is 15. Third term is 20. And fourth term is 25. Okay. And so on. Put dot dot dot. Is the required AP. Okay. That is the required AP. Please check. 15 minus 10, 5. 20 minus 15, 5. So we are getting common difference as 5. How will you get the next term? By adding 5 to the previous term. You will get the next term. Then take the second question. Do the same way. Second question. A means first term is minus 3. Common difference is equal to 0. So we will write T1 is equal to minus 3. D equal to 0. Therefore, T2 is equal to T1 plus D, which is equal to T1 is minus 3 plus, what is D? 0. Minus 3 plus 0 is minus 3. Okay. T3 is equal to T2 plus common difference, which is equal to T2 we got minus 3 plus 0. Again minus 3. Fine. In this way, T4 will be T3 plus D, which is equal to minus 3 plus 0 minus 3. Therefore, first term is minus 3, comma, minus 3, comma, minus 3, comma, minus 3, comma, dot, 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 is the required arithmetic progression. Over. Okay. Coming to the next question. Question number 3. First term A is given as minus 7. So we will write therefore T1 is equal to minus 7. What will be T2? T2 will be T1 plus common difference D, which is equal to T1 is minus 7 plus common difference is given as 1 upon 2. Kindly do the operation. Here no denominator means 1. Cross multiply. Minus 7 into 2 minus 14 plus 1 upon 2, which is equal to minus 13 upon 2. Next term. T3 is equal to T2 plus common difference. T2 just now we got minus 13 upon 2 plus common difference is 1 upon 2. Here this is easy because denominators are same. So minus 13 plus 1 upon 2 will give you, minus 13 plus 1 will be minus 12 upon 2. Minus 12 upon 2. Next, going to T4. T3 plus D is equal to T4. T3 just now we got minus 12 upon 2 plus common difference is 1 upon 2. Minus 12 plus 1 upon 2 will be minus 11 upon 2. 4 terms is enough. Okay. So 4 terms are enough. First term is 7 minus 7 comma. Second term we got minus 13 upon 2. Third term we got minus 12 upon 2. Fourth term we got minus 11 upon 2, comma, dot, 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 are the required AP. If you want to write the numbers as decimal numbers, that also is fine. Minus 13 upon 2, you will write it as 6.5, minus 6.5. This will be minus 6 and this will be minus 5.5. Okay, that way also you can do. Some I'll do 5th and 6th. You will be trying it on your own. So, first term, A is equal to first term is minus 1.25. Fine. T2 will be T1 plus D, which is equal to T1 is minus 1.25 plus common difference is given as 3. Subtract 3 minus 1.25. Put 0, 0. 10 minus 5, 5. 9 minus 2, 7. And 2 minus 1, 1. So you are getting it as 1.75. I know you can do directly, but to be double sure, just to do the working and check. So we got T2. T3 will be T2 plus common difference. So 1.75 plus common difference is 3. This is easy. This will be 4.75. Okay. T4 will be T3 plus common difference equal to T3 we got 4.75 plus D is 3, which is equal to 7.75. So we got 4 numbers, that is enough according to the series. Minus 1.25, comma 1.75, comma 4.75, comma 7.75, comma dot is the required AP. To check whether our AP is correct or not. Subtract and check. 1.75 minus of 1.25. Minus and minus will become plus. Add 0, 1, 5, 9, 10, carry 1, 3. Are you getting the common difference as 3? We got common difference 3? Yeah, it was given 3. That means we can be double sure that this AP is absolutely correct. Understood, no children? So please try 5th and 6th sum. Okay. This is a super easy sum. Find the first term and common difference for each of the AP. So here we need not check whether it is in AP or not. Already it is, the sequence is in arithmetic progression. We just have to write the first term and the common difference. So if this is the sequence, what will be the first term? T1 or A is equal to 5. First term is 5. D is equal to T2 minus T1, which is equal to 1 minus 5 minus 4. Okay. Check. T3 minus T2 minus 3 minus 1 minus 4. Yes, common difference. It will be same because they have already given in the question that this is in AP. So just write down first term is equal to A equal to 5 and D is equal to minus 4. Okay, common difference and first term. Same way you will solve all the sums. Fourth question I have copied. Same way, first term they are asking and the common difference. As we did the previous sums, let us give this as T1, 1 upon 4, T2, 3 upon 4, T3, 5 upon 4 and T4, 7 upon 4. Do the same way. The previous sum also write this and find out the common difference. So first term we already got 1 upon 4. What will be the common difference? T2 minus T1, let us do. 3 upon 4 minus 1 upon 4 will give you 3 minus 1 upon 4, which is equal to 2 upon 4. 2 upon 4 will be 1 upon 2. 2 ones are 2 2s. So common difference you are getting 1 upon 2. Show one more. For one more subtraction you show. That is, let us show for T3 minus T2. T3 is 5 upon 4 minus T2 is 3 upon 4. Subtract 5 minus 3 upon 4. 5 minus 3 is 2 upon 4. Again you will get it as 2. Yeah, that's what I said. Only show 2 subtractions and come to the conclusion. Final answer. First term is equal to A, which is equal to T1 is 1 upon 4 and common difference is equal to D is 1 upon 2. This is the answer. You don't need my help to do the second and the third sum. Same format you follow. First term For the second sum, what will be the first term? 0.6, 0.9, 1.2, 1.5. First term is 0.6 and D will be 0.6 minus 0. D will be, common difference will be 0.9 minus 0.6, 0.3. I hope you understood this introduction part of arithmetic progression. With more interesting sums, we will be meeting in the next class. Till then, bye and take care.